maximum and minimums, locals and absolutes. Okay, so local meant it was in a small window. They gave us an interval to look between. Absolute meant across the entire domain for a function. So being able to look at a graph and get the domain, being able to look at a function, get the domain, and think about those things. And then we looked at a graph on page 234 of our book and did those things with local maxes and looked at certain intervals to find those local maxes, local mins out of that. And I told you the next thing that we were going to do was talk about using the graphing calculator to help us find local maxes and mins out of that. So that's what we want to do next with that, and then do some other stuff. So example, I believe is using, and if you don't have your graphing calculator today, if you've left yours at home or yours is dead, grab one off the desk there, because it'll be handy to know how to do this, and nothing like pushing the buttons to learn how. So using the graphing calculator, or let's be smart about it, graphing utility, find local maxes. And if we can't put our phones on silent, we got problems, okay? I'm tired of hearing the chirps of text messages. Put your phone on silent, or I'll start looking for the phones. Okay, this is a college class. Put them on, turn them off, whatever you got to do. Okay, all right, so let's take a function. Let's do one that maybe we know something about. 3x cubed minus 7x plus 1 as our function. And let's find the local max over -2 to +2. So we use the graphing utility to do that. So what we need to do is graph that equation. So 3x cubed minus 7x plus 1 is what we're going to graph. So graph a calculator, y equals, clear out some stuff. Yeah, 3x raised to the third minus 7x plus 1. If you didn't have a graphing calculator, you would draw that graph by just making sets of ordered pairs. So if something were to happen in your graphing calculator was obsolete or quit working or something like that, you can still get a graph. All right, so the interval that they asked us to look at is from -2 to +2 on that graph. So what we want to do is hit second and the trace button, and that should take you to the calculate menu. Second and then trace gets you to the calculate menu. Notice you got a lot of options here. You got values, you got zeros, which we'll use a lot. We probably won't use the calculator as much to find them, but minimums, maximums, we can find an intersection if we got two different graphs. And here's a derivative and an integration. Those are both calculus things that we won't use, but we're looking for maxes and mins. So if we're going to find a local maximum, we're going to select option number 4. So you can either hit number 4 or arrow down and hit enter. And then it's asked for a left bound for that. So our interval was from -2 to +2, right? So what's the left side of that? It's -2. So we would just type in -2 and hit enter. Notice how it puts a little line right there. On the color ones, it does that. I'm not sure if the black and white does that or not. It's because the resolution is so small, it wouldn't draw a good picture anyway. But it asks for a left bound, and then it asks for a right bound. Okay, the right bound should be the other end of the interval, +2. So type +2 and hit enter. So on the color one, it shows you the window that you're looking in for that local max or min, okay? And then it asks us to guess, and you do want to move your cursor to where you think that local max would be, or pretty close to that. So where do we think a local maximum would be on this graph? What quadrant would it be in? Quadrant 3 is right here. So is that where the maximum is? Remember, quadrants are numbered 1, 2, 3, 4. So it's in quadrant 2. So I'm going to move my cursor to where I think it's close to the maximum there. I think that max is somewhere around right there. That looks like the top of that little hump in the graph. So I'm going to hit enter. I'm just guessing that that's what it is. The calculator is going to tell me, oh, you were just a tiny bit off. It's actually here at negative 0.881918. So several decimal places. We'll round that off. And then positive 5.115613 out of that. So let's round to 2 decimal places. Would be absolutely fine on that. So the local max in that interval would be at negative 0.88 and positive 5.12. Again, remember this is a point, an ordered pair. This is an interval. They look like the same thing when you write them down, but they're different things. You've got to pay attention to the context. So if that word over or inside, is there, you got to think, oh, they're not talking about an ordered pair. They're talking about an interval. So be careful about the context of reading that. So let's find a local minimum for that. So for the local minimum, how do we get back to that menu to find that? Second trace and option number 3 for minimum. And again, left bound is the lower side of your interval, so negative 2. The right bound is the upper side of your interval, so positive 2. The color ones have enough resolution to show you that little, okay, this is where we're looking. We're not looking anywhere else. And it asks us to guess. So I'm going to move my cursor to where it's close to that little spot right there. That looks darn close. Okay. Now we'll hit enter. And it shows me, oh, well, you were really close, but it wasn't quite that. It's positive 0.88. And then the y value for that is negative 3.12 out of that. So